a pair of dice is tossed. When you hear a pair means two. Don't forget when you talk about a pair of trousers, a pair of shoe, so it means that two things are done together. Now, for the outcome that we are going to have, I'm going to construct a table. Don't forget that when you toss a single die, you are going to have 6 different numbers coming out, which is 1 to 6 for a single die. That is the side that a dice are. Now, when you now have a pair of dice being tossed, it means that 2 dice are tossed. Or when you have a single die tossed 2 times. So what the outcome we are going to have is what I'm going to construct right now. Now, for this first die, 1, 2, 3, 4, 5, 6. And for the second die, we have this 1, 2, 3, 4, 5, 6. Then the arrangement will now come in this order. The outcome we are going to have will show up right away now. Now we now relate those numbers together with one another. We have 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Here 2 1. I mean 2 here, 1 this one is 2 2. This is 2 3. You get it like that. This is 2 1, 2 2 now. 2 3, 2 4, 2 5, 2 6. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Those are the the outcome that are giving us 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. That is the outcome that we are going to have when we toss a pair of dice. Now, the first thing we need to also look at here is that how many outcomes do we have now? 1 2 3 4 5 6. 1 2 3 4 5 6. 6 multiplied by 6, we are going to have 36. So we are having 36 total number of outcome. We have 36 total outcome. That is the total outcome we have when we toss a pair of dice. Now, go to the question now. The first question says that what is probability that the two numbers that will be obtained are odd numbers? Two odd numbers. Probability of two odd numbers will be equal to. Now, we need to look at what's those numbers that are odd number. We are going to fish them out now. Now, if you look at it very well, 1 is an odd number. What is an odd number? Odd numbers are numbers that are not multiples of 2, that are not divisible of 2. Now you talk about 1, 3, 5, as we have it here. 1, 1, 1, this is 2 odd number. 1, 1, I use this symbol now to represent them. 1, 3, 1, 5. 2 is not an odd number. So there's no value that's going to be among them here because the two numbers must be odd number. So we also have here 3 1, 3 3, 3 5. We move here. 4 is since 4 is here, 4 is not also an odd number. So we move here. That's 5 1, 5 3, 5 5. So we are having non-odd numbers and what? So you have total number of odd numbers. Odd numbers are 9 numbers. We have 9 numbers that both of them are odd numbers. So the probability of all two odd numbers now will be equal to 9 over 36. That is probability of odd number divided by the total number, which when we divide it further, we are going to have 1 over 4 as the final answer. Now, the second question, this is the first question, answer to the first question. The second question says that what is the probability that we are going to have a sum of 8 and or a sum of 12? Remember, sum of 8 or sum of 12. Sum of 8 or sum of 12. Now, for us to have a sum of 8, let's look at those numbers that when we add them together, we are going to get 8. If you look at all the numbers here, it's only this one you can add together to get 8. Now, when you are given a question of this nature, when you get to that first number that is equal to 8, if you look at here, no number is equal to 8 here. The last number that we have here, 1 plus 6 is 7. But the first number, this last number here is 2 plus 6 is 8. So look at the diagonal position of that particular number that you find as the first 8 there. When you add it together, if you look at it very well, you discover that all the number in this diagonal are sum up to 8. When you add them together, 6 plus 2 8, 5 plus 3 8, 4 plus 4 like that. Now we have been able to have how many numbers that are sum of 8? 1 2 3 4 5. That is going to be equal to 5. Probability of sum of 8, probability of 8 or 12 will be equal to 5 over 36. Don't forget in probability, when you have or coming up, or is going to be addition of those probability values plus, and when you have and, either or, that is mutually exclusive event. When you have and, that is independent event, you do what? You do the multiplication of those values. Now, what we have here is or, so let's continue with or sum of 12. If you look at all the numbers that we have here, none of them can sum up to 12 except the last number here, which is 6 plus 6, which is 12. Any other number cannot sum up to make it equal to 12. So in that regard, I pick this. This is what? Just only one value. That is 1 over 36. How to find the LCM? Let's 36. That's 5 plus 1 over 36. That's what to be 6 over 36. Is equal to what? 1 over 6. Now, probability of obtaining sum of 8 or sum of 12 is going to be equal to 1 over 6. Now, for the next question. The next question says that what is the probability that the two numbers will be prime number or an odd number? That is what the question says. So probability of prime number, prime, or odd number. Don't forget that we have earlier find out the probability of odd number, which has been gotten to be equal to 1 over 4. In this case now, let's look for the probability of prime number. What is a prime number? Numbers that are not divisible by, they have two divisor, 1 and itself. They have two divisor, which is what? 1 and itself. So now, prime number can now start from here. That is 2, 2. I use this circle here. I use this 2, 2, 2, 3, 2, 5. All prime numbers start from 2, 2, 3, 5, 7, and so on and so forth like that. Numbers that has two possible divisor, which is what? 1 and itself. So you cannot even mention 9 as odd number. So we also have 3, 2, 3, 3, 3, 5. Thus we haven't now 6. 4 cannot be. Then we have 5, 2, 5, 3, 5, 5. So we also have 9 numbers that are odd, that are prime numbers. Now, so probability of prime number is 9 over 36, or which is what? Mutually exclusive event, which is going to be, we're going to put all there plus probability of odd number, which is also Odd number has been gotten before. Don't forget that is 1, 1, 1, 3, 1, 5. So we are having how many odd number 2? We are having 9 odd numbers 2. 9 over 36. So that is going to be equal to 36 here. This is here. This is what? This is here. 1, 9 plus 9. That's what? 18 over 36. Which gives us probability of prime or probability of odd will be equal to 1 over 2. Will be equal to 1 over 2. That is how you solve a question that has to do with tossing of 2 dice, or when you toss a pair of dice, or if you try to toss a die at the same time you toss it twice and you are asked to find the values or the outcome that is going to show. You need to first of all show this table in this order like this, then you continue from there to solve your problem further. So we have here is talking about different color of ball that we have inside the bag. Now let me read the question. The question says a bag contains 6 red balls and 5 black balls. 6 red, 5 black. I use R to represent red and B to represent black. Now 6 red ball and 5 black ball. Now the question now says 2 balls are picked at random from the bag. What is the probability of obtaining? The first question, I want to provide the answer to it now. The question is here already. What's the probability of obtaining when the balls are picked that both balls are black? The second question says the first ball is black. And the third question says they both are of the same color. Now, there is now a clause there. It's given that the balls are picked one after the other, number 1, for the condition without replacement, and the other one is with replacement. Now, to answer the first question now, we are going to split the question into 2 parts. We are going to have the part of without replacement, and we are going to have the part of with replacement. Now, without replacement. Now, for the first question, it says 2 balls are picked. Probability of obtaining both are black. Probability of obtaining both are black. Now, from here, we can see that the total number of ball here, total number of ball is 6 plus 5, which is 11 balls. We are having 11 balls inside the bag. Now, when we have 11 balls inside the bag, they say both balls are black. The first question. Probability of both balls, both black. Now, that will be equal to the first. It means that the first one that you pick is a black ball. Probability of obtaining a black ball will be probability of how many black balls do you have there? 5 black balls over total number of balls that we have there. Now, for the first pick now, 5 over 11. It is the first is black. When you want to now say it, you say the first is black and the second is black. Don't forget in probability, when you have and, it means it is an independent event and will give us multiplication and multiply by both black. First is black and second is black. And you have to consider this condition here without replacement. It means that once the first ball is picked out, it is not replaced back there. If it is black that is picked, as we have said it here, the number of black will have reduced by 1, which will have turned into what? 4 over, and the total number of balls that we have there will have also reduced by 1, which is going to be 10 now. I think it is clear to all of us. The first ball, which is 5, and the total number of balls is 11. That is the first pick, which is black. And another black again. The black that is there, if the first is black, it means that the number of blacks will have reduced by 1, which makes it to become 4 now. And the total number of balls that we have there will have as well reduced by 1, which makes this to be equal to 10 now. We can now whatever we can be. We took out there 5 here 1, 5 here 2, 2 here 1, 2 here 2. So we're going to have it to be equal to what? 2/11. That is the answer, that the both balls are black. Now, I'm going to do it one after the other. Now, I'm going to have the one with replacement now. With replacement. Now, for the probability of both black, probability, both black. So it means that when you are going to have replacement, it means that immediately you draw the first ball, it is black. You have the choice of probability of black, and you return the ball back there, which make the ball to be the number of ball to be intact there back. Then you pick the other one again, is also black. So probability of both black will now be equal to the first pick, that's 5/11. First is black and second is black. Multiply by 5/11 again, which is going to be equal to what? With replacement. Don't forget, that will be 25/121. 25/121. That is, both are black. Now, the second question. I move to the second question now. The second question says that the first is black. The first ball is black. Now, let's start with our without replacement. Without replacement. The first is black. So if the first is black, it means the second one that will be picked will be red. So that will be what? Probability of black and probability of red, which is going to be equal to the first is black. That is going to be how many black? 5 over total number of balls 11, and multiply by the first is black, and we cannot say or the second, and the second is red. The first is black and the second is red. This first is black and the second is red. The second will now be red, which is what? How many balls do you have? 6 over. Now, for the value here, don't forget it is without replacement. The total number of balls will be reduced here. Even though, you can see that the reason why this red is not reduced by 1 is because it is this red that is not picked. It is not the first ball that is picked here. So it cannot be reduced. So the red is still intact there as we have it in our probability. Then the number of balls that will be that a total number of balls will have reduced by 1 because it is without replacement. That will be 10 now. 5 here, 2, 5 here, 1, 2 here, 1, 2 here, 3. So that will become 3/11. That is when you have the first ball being red, being black, and the second being red. They only just say the first ball is black without replacement. That is 3/11. Now, which replacement now? With replacement. Now, with replacement, the first is black. That will be what? First ball is black. First black. And the second red. So that will be, first is black, that is 5/11. We now return the ball back there and multiply by 6/11. That will be equal to 5 times 6, that's 30, all over 11 times 11 is 121. 121. That is with replacement for that second question there. You can see with replacement, the total number of ball here does not reduce. It just remains because it has been replaced there back into the bag. That is why the number of ball, total number of ball is not reduced. Likewise, the ball, whether it is red or whether it is any other color, it is not going to be reduced. Now, the next question, which is the third question here, the question says that the probability of picking both are of the same color. Both balls are of the same color. So in that regard now, you pick two balls. It means that the first is either you have the first is black, second is black, or the first is red and the second is red. So let's start with without replacement. Both of same color. Let's start with without replacement now. Without replacement now. Now, for without replacement, first is black, first black, second is black, and second is black, or first is red, and second is red as well. So this will be, first is black, that is 5 over, what's the total number? 11, without replacement. Don't forget, they did not return it back. 5 over 11, multiply by, and second is black as well. That will be 4 over 10, or plus first is red, that is 6 over 11, multiply by, second is red, that's about 5 over 10 as well. So we have in, you can see the way the expression looks. So we are having this one now to be divided by this. This one is 1, this one is 2, this one is 1, this one is 2. This one is 2 over 11 plus this one is 1, this one is 2, this one is 1, here 1, here 3. That's 3 over 11. So which is we're going to find the LCM. 11, that's 2 plus 3 over 11, that's 5 over 11. That is without replacement. First is black and the second is black, or first is red and second is red. That is when you have both balls that are picked, they are of the same color. Now, with replacement now, with replacement. Now, with replacement now, is that we have first is black, second is black, or first is red and second is red. You can as well just put red first. First is red, second is red, or first is black and second is black. You are going to arrive at the same answer. So let's look at it in this way now. First red, second red, or first black, second black. Now, first red, second red, that will be the first red, that will be, don't forget, with replacement, that is 6 over 11, and multiply by, second is red. They have returned it back there. That will still be what? 6 over 11 as well. Or plus, first is black, 5 over 11, multiply by, second is black as well, 5 over 11. The ball has been replaced back. It has been returned back into the basket after the first pick. So the total the number of red does not reduce. Likewise, the total number as well. The same thing happens to the black ball as well. So we are having 6 times 6, 36 over 121 plus 25 over 121. Where we have it, LCM to be 121. 36 plus 25. 36 plus 25, because the LCM there is 121. That will be equal to 61. 61 over 121. 61 over 121. That is the answer there for when it is with replacement, when the both balls that are picked at random, when they are of the same color. This kind of question, it requires you to be very, very careful when you are trying to solve it. You have to be considerate about those meaning of those terms, that is mutually exclusive or independent event terms, when you are making use of or, either or, and both. You have to be very careful when you are making use of them. Then also you have to as well take note of when you are trying to do your without replacement and with replacement. It is very, very important. So with all this at the back of your mind, probability will be an easy question to solve. Still more questions. Identical ball in his bag. Out of them, 3 are black. Let me write the 3 blacks out. 3 black. I call black the okay like this. And 2 are blue. Blue. I represent blue like this. Blue. Then the remaining are red. Don't forget that the total ball that we have that has been shown to us earlier while we are reading the question is that Tyson has 9 identical ball in his bag. So out of the total number of balls that are 9 ribbon, 9 ribbon in his bag. Now, those 9 ribbon, 3 of them are black, 2 are blue. So the remaining ribbon will be red, which are what? 4. If you add everything together here, you're going to get 9. So now we've been able to get the value of those balls out. Now we have the total number of balls that we have there already. Then let's move to the question proper. The question says that if a ball, look at it, if a ribbon, look at the question, if a ribbon, it doesn't say 2, if a ribbon is picked from the bag at random, what is the probability that it is the A part of this question now? Probability that it is not red. Then 2, it is not blue. Now, for us to solve this question, we want to simplify this first before we move to the second part of the question. Now, for us to solve this question, we know that the probability, we have to solve out the probability of the ball of picking a red ball. And we have to also solve out the probability of picking a blue ball first. Now, probability of a red ball will be equal to, what is the number of red ball that we have here? 4 over 9. While probability of picking a blue ball, blue, B-L-U, will be equal to, blue will be 2 over 9. Now, probability that it is not red, according to what we have here, is going to be 1 minus probability of picking a red ball. So whenever you are given a question that is trying to tell you that the probability of a particular event is this, and what is probability that it is not that thing, how you solve it is by just saying 1 minus probability of that event coming into being. The way I'm going to do this one right now. Now, probability that it is not red will be equal to 1 minus probability of red. So which is equal to 1 minus, what's probability of red? 4 over 9. In this regard, I have to find the LCM because this is a fraction here. 9, that will be 9. 1 in 9 in 9, 9 times 1, 9. Minus 4, that will be 5 over 9. That is probability that it is not a red ball that is going to be picked from the bag. Now, for the probability that it is not blue, we are going to as well follow the same method that we use to get the first question, or the first answer here. Probability that not blue will be equal to 1 minus probability of blue, which is equal to 1 minus, what's the probability of blue? 2 over 9. We find the LCM as well. That's 9 minus 2. That will be 7 over 9. That is probability of not blue is equal to 7 over 9. While probability of not red is 5 over 9. So we've been able to get that answer for the first part of the question in that order like that. Now we move to the second part of the question. The second part says, if two ribbons are drawn at random, one after the other, what is the probability that both of them will be black if there is no replacement? What is the probability that, number one question says, probability that both black if no replacement. If no replacement. Both ball that will be picked at random will be black if there is no replacement. Now, which means that you pick the first ball, then you pick the second ball at all. Now, if no replacement means that no replacement. It means that by the time you draw the first ball out, you don't return it back into the bag again. Then you draw the second ball, which means that you should have known that after you have picked the first ball out, a particular value has been reduced. That is, the total number of balls there will have been reduced by 1. And if it is the probability of the same ball, the same color, which means that same color will also reduce by 1 again. Now, both are black if no replacement. So probability of black ball, of picking the black ball, will be equal to 3 over 9. Because we are having 3 black balls there, then the total number of balls that we have there is 9 balls. 3 over 9. 9 ribbons, sorry, that will equal to 1 over 3. 1 over 3. That is the probability of picking a black ball. Now, for picking a black ball, with no replacement. So the first is, it means that the way you are going to do the translation of this particular question is that by you saying, you're going to say the first ball is black and the second ball is black with no replacement. Take note. And you know, when you make use of and in your probability, when you make use of and, you are going to multiply the two probability with one another. So probability of picking the first ball as black, that is 3 over 9. Probability of both black, no replacement, 3 over 9. And the second two is also a black ball. The second two is also a black ball, and that will be multiplied by second ball, also black ball. Don't forget, there is no replacement after you have picked out the first ball. That will be 2 over, then this 9 too will also be reduced because this is the total number. This black ball has been reduced to 2 because it is the probability of that same black that we are doing for the second ball that is going to be drawn out. That the second ribbon that's going to be drawn out. So that will be 2 over, what total number of ribbon is 9. So now we are going to have the ribbon now to be reduced to 8. So we are going to have it to be 2 here, 1, 2 here, 4, 3 here, 1, 3 here, 3. So we are having 1 over 3 times 4 is 12. 1 over 12. Both black with no replacement. Now, the second question raised and says that both ribbons, if the both ribbons are blue, if there is a replacement. Both ribbons are blue with a replacement. Yes. Both blue with a replacement. Now, what is the probability of picking a blue ball? Probability of blue is equal to, how many blue do you have there? 2 over 9. So it means that the first ball is blue, you pick it out, then you drop it back with replacement. You return it back into the bag, and you take another ribbon to find out the probability of picking that as well as blue. Now, there will be probability of both blue with replacement will be equal to 2 over 9. First is blue and the second is blue. and multiply by, there's a replacement. The blue number will still remain 2 again because it has been returned back into the bag. Over 9. The total number of ribbons as well will not change, will still remain the same value because the first ribbon taken out has as well been returned back before the second drone is taken. So this will give us 4 over 81. 4 over 81. So that is the answer to that question. Probability of a civil servant owns a car is 1 over 6. Probability of civil servant owns car is equal to 1 over 6. Now, find the probability that, according to the question, we are asked to find the probability that 1. The first question, we're going to solve the question one after the other. 1. Find the probability that 1. 2 civil servants X and Y selected at random each owns a car. X and Y owns a car each. Each civil servant X and Y selected at random, each of them owns a car. And we have been told that probability that the civil servant who owns a car is 1 over 6. That one has been given to us. Probability of a civil servant owning a car is 1 over 6 already. Now, probability that X and Y owns a car is now going to be X owns a car. That's how we are going to do the translation. That is, Mr. X owns a car and Mr. Y also owns a car. That is, X owns and Y owns a car. So which is going to be, what's the probability of owning a car? 1 over 6 and means multiplication. And 1 over 6, which is going to be equal to 1 over 36. Probability of X owns a car and Y owns a car as well is 1 over 36. Then to the next question. Answer to the next question now. The next question is that of the civil servant P and Q selected at random, only one owns a car. We have now selected 2 civil servants, but only one of them owns a car. In that regard, we have known the probability of a civil servant owning a car. What is the probability that a civil servant does not own a car? That is what we need to firstly solve out here. Probability of civil servant not own a car will be equal to 1 minus probability of civil servant own a car, which is equal to 1 minus, what's probability of civil servant owning a car? 1 over 6. You find the LCM of that, that's 6. 6 minus 1, which is 5 over 6. Now, probability of a civil servant not owning a car is 1 over 6. But from the question given to us, as that of the second part of the question given to us here now, it says that of the 2 civil servants selected at random, the 2 civil servants are given the symbol of P and Q. Only one owns a car. We do not know the particular one that owns a car between the 2 of them. So it means that either P owns a car, Q does not own, or Q owns a car, P does not own a car. We are not told the particular one of them that does not own a car. So we need to work out the probability now. So now, it's either P own and Q not own, or Q own and P not own the car. So that will be P own is 1 over 6 and multiply by Q not own a car, that's 5 over 6, put it in bracket, or plus Q owns a car that is 1 over 6, then multiply by P does not own, that's 5 over 6. So that will be 5 over 36. That becomes 5 over 36 plus 5 over 36 as well. So you have to find the LCM right now. 36, that's 5 plus 5 for the 6. That will be 10 over 36, which is going to be equal to 2 here 5, 2 here 18. So the probability that of the two workers selected, only one of them owns is 5 over 18. Now, we move to the next question now. The next question says that out of 3 civil servants A, B, C selected at random, only one owns a car. Out of the 3 civil servants selected, out of 3 of A, B, C civil servant, only one owns a car. Now, in this regard now, it means that if we say A owns a car, B will not own, and C will not own. Or A do not own, B own, and C do not own. Or A do not own, B do not own, and C own a car. That is the probability of what we are going to work out right away now. It means that A own, B not own, C not own. Or, don't forget this and, or A not own, B own, C not own. And, or A not own, B not own, and C own a car. So that's the probability of what is going to happen if only one of the 3 of them owns a car. So we are going to have it this way now. So now it's going to become A owns 1 over 6 and multiply by B do not own, that's 5 over 6 times 5 over 6. The same thing applies to everything here because the same value is what is going to run through them. And the arrangement might be different. That is going to be 5 over 6 times 1 over 6 times 5 over 6 plus 5 over 6 times 5 over 6 times 1 over 6. So we are going to have, this is going to become 25 over 6 times 6 times 6. That's 216. 25 over 216 plus 25 over 216 plus 25 over 216. We have to find the LCM of this one, which is going to give us, LCM is 216, that's 25 plus 25 plus 25. That becomes 75 over 216. When we simplify it further, we're going to get 25 all over 72. 25 all over 72. Those are the that's the answer when only one of the civil servants out of the 3 civil servants selected owns a car. The 2 hunters, P and Q, aims at a target. At the same time, I'm reading the question now. The question goes further and says, probably that P is the target, P is equal to 2 over 9. While the probability that Q means the target, Q means is equal to 6 over 7. What is the probability that, number 1, A, only one of them hits the target, B, 2 of them miss it, C, Q only hits it, D, none of them misses it, E, one of them miss the target. Now, in this regard, you can see that we have been given the probability of P hitting the target and Q missed the target. you can see from our question, we've been able to go to the question very well. What we need to do again is to look for the probability of P meets the target, because you can see from the question they are talking about the two of them meets the target, all those kind of. So you have to work those one out first so that they'll be useful. By the time you need them, you'll be able to make use of them with ease then, because those are the numerical value you are going to make use of in solving your probability. Now, probability that P meets the target now, that will be equal to 1 minus probability of, is equal to 1 minus probability of P hit the target, which is equal to 1 minus 2 over 9, and that is 9. That is going to be 9 minus 2, that is equal to 7 over 9. That is P miss the target is equal to 7 over 9. Now, we need to also find probability of Q hit the target, which is going to be 1 minus probability of Q missing the target. Q hits the target, probability of Q hit the target will be equal to 1 minus probability of Q miss the target, which is equal to 1 minus 6 over 7. We find the LCM, 7. 7 minus 7, 7, 1 times 6, 6. That will be equal to 1 over 7. That is probability of Q hit the target is equal to 1 over 7. That is the probability of, we have the probability of the hitting of the two by the two of them and the missing of the target by the two of them. We have those values of the probability at hand right now. So we can now go ahead in dealing with our questions properly, providing answer to those questions accordingly. Now, let's start from the first part now. A. The first part says that only one of them hits the target. The two of them aim at the target. The probability that only one of them hit the target is, we do not know the exact one between the two of them that will hit the target. So we can now say that that will be either P hits the target and Q miss it, or P miss the target and Q hits the target. That is the meaning of that. So now P hit the target, that is going to be equal to 2 over 9, and that is multiplication. Q miss the target, Q miss the target, that is Q miss the target, that's 6 over 7, or R plus P miss the target, that is 7 over 9, and multiplication. Q the target, that is 1 over 7. I think you know that this is very simple to approach. You can see that where we have the hand, I put multiplication there, and where I have the or, I put the addition value there. Now, I cannot go ahead. So this will become, what can we call each other? Let me call this 3a 2, 3a 3. Okay, nothing to gain. 2 times 2, 4 over 21 plus 7 here 1, 7 here 1. So that'll be 1 over 9. 1 over 9. 1 over 9. That is the Q, any one of them is the target. Now, for me to now find this value here, I have to find the LCM. 21 times 9. 21 times 9. That's 9 times 2, 18. 189. 21 in 189, that's 9. 9 times 4, that is 36. Plus 21 times 1, 21. That is going to be equal to 57. 57 all over 189. That is the probability of one of them, only one of them hit the target. That's gonna become 19 over 63. 3 here, 1, 3 in 27, that's 9. 3 in 18, that's 6. 3 here, 3. 19 over 63. That is the answer to the particular question there. That is, only one of them hit the target. Now, the next question says that two of them miss the target. B. The two of them miss the target. It means that P missed the target and Q missed the target. That is very simple. That is, P missed the target and Q missed the target. That will be equal to, what's the probability of P miss the target? That is 7 over 9 multiplied by Q means the target as well. That is 6 over 7. This one called is 2, 3 here, 2, 3 here, 3. That is 2 over 3. Very simple to approach. Now, we move on to the next one. That is the C part of the question. The third question says that Q only hits the target. Q only hits the target. Now, this means Q only hits the target. It means that Q is the target and P miss the target. That is just a simple expression of that particular question there. It means Q hits the target and P miss the target. Q hit the target and P miss the target. That will be equal to, what is the probability of Q hit the target? 1 over 7 and multiply by P miss the target. That is going to be 7 over 9. I call it, that will be equal to 1 over 9. That is 1 over 9. That is very simple there. Then the D part of the question, says that none of them misses the target. None of them misses, which means that P do not miss the target as well. Q do not miss. It means P hit the target and Q hit the target. P hit and Q hit the target. So this will become P hit, that is probability of P hit in the target, that's 2 over 9 and multiply by Q hit the target, that is also what? 1 over 7. 2 over 9 multiplied by 1. That will be equal to what? 2 times 1, 2 over 9 times 7. That will be equal to 63. That's 2 over 63. Now, to the last question. The last question says that one of them missed the target. One of them missed the target. We do not know the exact one amount. So it means that it's either P missed the target, Q hit it, or P hit the target and Q missed it. So one of them missed the target. That is, one of them hit the target. That's P. Is either P miss, one of them. It says one of them misses it. P miss and Q hit, or P hit or Q miss. Now that will be, what is P miss? P miss is 7 over 9 or times, that's, and times Q hit the target, that's 1 over 7, or that is what? Plus, put this in bracket, P hit the target, that's 2 over 9, 2 over 9, and Q means the target, that's 6 over 7, that's times 6 over 7, 6 over 7. So this will become, this one circle this one, that's 1 over 9 plus 3 here 2, 3 here 3, that's 4 over 21, 1 over 9, 4 over 21. So we find the LCM of that one. 21 times 9, that is equal to 189. 189 over 189, and that will be equal to, we also that we have 9 21, that's 21 times that, we're going to have 50, it will be equal to 50, 57, 57 over 189, which is equal to, you're going to get the same answer like the one we have here. That will be equal to 19 over 63. That is the final answer there. That is 19 over 63. That is when one of them misses the target. We do not know the exact one of them that misses the target, so we have to work it out that way. A fair dice is rolled once, and 2 unbiased coins are tossed once. Now, the question says, what is the probability of obtaining a 3 and 2 tail? Now, I'm going to give the outcome of what that particular question is saying. I will now be able to draw the our expectation on it. Now, a fair die, we have this to give us. We're going to have this 1, 2, 3, 4, 5, 6. That is what the outcome that a fair dice is going to give to us. 1, 2, 3, 4, 5, 6. Don't forget, I have been able to show you in this class when you toss 2 dice or when you toss a die twice. I've shown you how the table is going to look. Now, this is when you throw a fair die. Just a dice, just throw it. This is the outcome we are going to obtain. Now, the question also goes further and say that 2 unbiased coin. 2 unbiased coin is tossed once. 2 coins. Don't forget that a coin has a head and a tail. Now, for 2 unbiased coin to be tossed, we are going to have it in this way. This is the head. This is the tail. This is the second one. Head, tail, head, tail. We are going to have the result to be head, head. This is when you have 2 unbiased, 2 coins tossed, or when you toss a coin 2 times. Head, 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 tail. You can see head, head. You can see how the line goes. Head, tail. We are through with what is going to happen here for 2 unbiased coins. Then we'll come here. This is tail. This is tail, head, tail, head. This is tail, 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 tail. I think that arrangement is gotten by you. This is how we have the arrangement of 3 arrangement or 3 diagram for the tossing of a coin. Now, this one gives us head, head, L, tail, tail, L, tail, tail. That is what we obtain as our outcome for tossing 2 coins. Now, to the question now. The first question, A part, it says probability of obtaining 3 and 2 tail. What is the probability of obtaining a 3? Probability of 3 and what? 2 tail. 2 tail. Now look at 3 here. From the dice, probability of 3 is 1 over. There's only 1 3 that we have there, just 1. How many outcomes do you have there? 6. 6 and multiplication and 2 tail. So from this outcome here, where do you have 2 tail? This is what? Only 1 place here. And what is the total outcome here? 1, 2, 3, 4. 1 over 4. The answer is 1 times 1. 1 over 4 times 6 is 24. 1 over 24. That is the probability of obtaining 3 and 2 tail. Now, the next question goes further and says that what is the probability of obtaining a odd number and 2 head? Probability of odd number and 2 head. Now, what is an odd number? Odd numbers are numbers that are not multiples of 2, starting from 1. So, from here, those numbers that are not multiples of 2 are 1, 3, 5. So, that will be odd number. How many odd numbers do you have there? 3. And the total outcome here is 6. And multiply by 2 head. This is the only place where we have 2 head. There's only 1 head we have here. It's only 1 head here. We don't even have head here at all. So we have, this one is what? 1 over, what is the total outcome? 1, 2, 3, 4. 4. So we have this one to be 3 times 1, 3 over 6 times 4 is 24. So we can cut it further to become 3 here, 1, 3 here, 8. 1 over 8. That is the answer to that for the second question. For the third question, the C part, it says that what is the probability that we are going to obtain 4 and 1 head? Probability of obtaining 4 and 1 head. 4 and 1 head. Probability of obtaining 4 here. You can see we only have 1 4 here. That's 1 over, what is the outcome? The total outcome is 6 and multiply by 1 head. 1 head, this is 1 head here, and this is 1 head. It does not say at least 1 head, it just says 1 head. So we have 1 head here, we have 1 head here. So we have it 2 times. That's 2 over, total outcome here, 1, 2, 3, 4. 4. So we can call this 1, this one 2. So we have 1 times 1, 1 over 6 times 2 is 12. So this is 1 over 12. That's probability of obtaining all this set of information here. Very simple to approach. More of the class is still coming. We implore you to subscribe to our channel so that you'll be able to have access to all our lectures.